Alright, so let's discuss on how we can actually represent the parse data, parse code in our program, right? So how can we do that? Let's say we have got our scope in there, for example, the function. Let's see how the program is structured. This entire thing is a scope inside the function is prime. Now these are the statements inside that scope. This is a statement, this is a statement, this is a statement. This is again a statement, and the statement has a scope inside it. Alright. Now this itself is a statement as well as a scope. There are two types of statement: a normal statement, a statement which is also a scope. Again, this is a statement which is also a scope. Now again, this is a statement which is also a scope, and inside that there is a statement which is also a scope. Okay. This is nested. We can do it recursively. Now how are we going to do that? Let's see. Let's say we have a struct for representing our data. Struct AST. I'm calling it AST, but it's not exactly AST. It's a very simplified version of AST. Like AST has expressions, things like numbers, expressions, operations, a lot of complicated stuff. Then you compress. Once you build the AST, you compress it, remove unnecessary nodes, optimize it. There are a lot of things. Our language, the goal is to be simple, right? So we are just going to have something that resembles an AST, but it's not going to be a real AST. We can't say it's a real AST. So what is it going to have? Well, AST node is going to have a statement. AST node is a statement. This is a statement. Statement. Right? There are two types of statements. Right? What are they? Either they are let's define it. Statement type. What? Statement type. Normal. Statement type. Scope. What? Scope. Alright. Right. Now it will have a int statement type. We have a statement type. Now what exactly is inside a statement? How can we represent each statement? Right? For example, what exactly is a statement? Statement by statement, I mean this xcv and declare n, and this itself is a statement. Right? If you separate it out, if you just rewrite this into a statement wise. Now we have written it for convenience, but as I said before, if you just write all this one in a single line, that's no different. Let's make it more convenient and separate the statements. This is a statement. This is again a statement. This is a statement. This is a statement. This is a statement. Alright. If you think about it, then you can understand what exactly is happening out here. While is a statement, and then there's the operations out there. This is again a scope, kind of a scope. These are again statements. So you cannot declare a variable out here. This has to be an operation. Also, I think I may allow declaring variables out there. Let's see. Again, let this be a scope one. Alright. Again, this is a statement. If again this is a scope, because this is again an individual block of code that allows you that's purpose is to push in a single byte, and that is a single boolean, right? Single boolean or integer, whatever. Again, this is a statement. Again, this is a statement. Each individual line is a statement. Now, I'm not separating the statements out there, but these are individual statements, right? These are individual statements. And this is a statement. This is a statement. This is a statement. Each individual logical unit is a statement. Now this is a scope. Let's just separate out the scope. So that exactly is that. This is the scope. This is the scope. This is inside the scope. Now this is inside the scope. This is inside the scope. This is inside the scope. Alright. And this is inside the scope. If and scope. Again. If where is the if? Second if. This is inside the scope. Alright. This is inside the scope. This will be outside. Again, this return. False return. This are our statements. We just think about it. These are our statements. These are logical separate groups, right? So how can we parse them? How can we represent xcv? We declare a variable double type name n. What exactly are we requiring? A string, a type info, and here like opcode info, like opcode the instruction info. Here what are we doing? We are pushing an integer or pulling out an n, the value of n. Now if we've already encountered this, we know what exactly the value of what type n is, what size n is, right? So we don't need we've got our type and size. So we're just pulling out the value. So what do we need to represent this information? We need instruction that is pulling out a variable and the name of the variable, the string. Let's see the function. So declaring a function name is prime. What exactly do we need to represent that? The function thing is instruction, and this is again a string. Same thing goes for this. There's this. Oh, what exactly are these? These are simple instructions. What exactly do we need for representing a single instruction? Alright, struct statement. What exactly do we need in a statement? Instruction. Okay. Int 6. Let's just include one more thing. That will require. Int val double val. Alright, double val int val. Exactly. And is there any other thing? And character val. Now we are not going to use all these variables always. We're just going to have it because easier to declare all that stuff from before. Now this is done. Next thing we need is a string, right? Character name. Let's keep it around 4096. Now, this is a bit controversial because if there is a string literal, for example, I'm not showing a string literal out there. Let's say func main and now let's say we are calling the way to use strings. Enter a number and then put s, and then we are just doing we're putting in the pointer of the number. Say declare dec v n integer. And this should not be an integer, double should be an integer here, integer, and then again pushing in the value of pointer of n, and then input input. Now what input will do is smartly decide the value, decide the type of n and take input of n. For example, if n is a string pointer, character pointer, it will take input a string. For example, if n is a number, it will take input a number. If it is a double, it will take input a double. Oh, it's a smart instruction. Right? Again, I'm not putting it in order of yes, like not separating statements, but rather writing code, really readable code. Right? Now we're taking input of n, and then again we're pushing it n, and then again we're calling is prime call. After calling is prime. Now each function will have an ID that the compiler will generate. Rather, this will push the ID of the function. Alright. Now this is done. So this prime is going to be called. Next is to call. Oh, we have already called this prime. So again, true or false is already pushed in. Now if now to check if pull in the value, right? We can do this and then pull in the value in the n itself, because then if n again it is prime. Yes, yes. We need to do this too. Now we have got string literals, right? So this string literal too will be stored in this name, str. Now I'm keeping it 4096, but this is a discrepancy that what if this is a huge string literal that is more than 4096 size? Now, that's the thing, like you might want to allocate this dynamically. However, I'm not going to do that, because again our goal is to design a simple programming language, not a powerful one. Now we've got that. Parse it. Now one thing that you need to see is, yeah, alright. If you just parse this now, alright, there is a bug, For example, what I mean is, if you see carefully, if you look carefully, you see enter and number, these are getting parsed as separate tokens. However, we need a string to be inside a same one, right? So how can we do that? If this equals to a code, alright, I'm not going to have single characters at all, because like our programming language is not going to support this at all. This is 65 is better. That's an integer itself. 65 is better. Again, to do simplicity. Again, if this is a code character, return next string token. Okay. Again, character pointer buffer. Let's just copy this first. Alright, boolean return true while buffer index equals to 0. Now we are just going to loop through. Example, while again this not equals to again a closing quotes. What it will do is str or rather buffer index plus is equals to this plus. Alright. Now the important thing is if this equals to a backslash, what will we do? So this is interesting thing, because we need to have it right. We need to parse the escape character. Parse escape. What will we do is we'll parse escape this plus one character again, and we are going to set that to this plus. Plus. We just going to increment it and then set it up there. Or rather, no, that's going to be an issue. Plus is equals to plus one. We are going to set the next character. For example, let's say we have in a string, we have got hello /n. Now what will we do is, if we have encountered this backslash out there, so we are going to replace this n out with the actual backslash n character, is this. So this is going to become this, alright. So what will happen? Then we are just going to read this character itself, alright. Then we do that again. We have to write this parse escape thing. Also, we are done, right? We have just parsed the backslash character. We're done. Next character is changed, so we will do that and we'll automatically update to the next character. That's it. Again, one more thing for the checking out here, that this is not equals to 0. Like suppose there is a syntax error. Now I'm not considering syntax errors now. Like this is a language where it is very difficult to make a syntax error. However, that it is possible, but I'm not going to catch it for now, because again we have to make it simple. So just avoid it for now, right? Character parse escape sequence, which was C, alright. Switch C. Now break is not required. We're just going to return things. Return 0. Alright. Case is n. Return /n. Case is going to be t. Return /t. It's going to be r. Return /r. It's going to be what exactly? What else are there? A. It's going to return /a. It's going to be what exactly is there? Return this. Quotes. It's going to return quotes. With this, it's going to return this. I guess that's it for now. Last thing. If it's backslash, it's going to return backslash. Now we're done. And we're just going to replace that. Yeah, we're done. And that's supposed to be it. Let's just try it. And there's a bug. And that's there should be a plus up here. I guess this might work. Let's see. That's still not working. Our first character is this. We need to increment that. Have to increment that. Plus up here too. Alright, so what? Let's skip the end. 1, 2. Exactly where is it crashing? Goodness. Again, we are going one step too far. Input data plus 1. Input data plus 1. And this plus. Sorry. Now let's just try it again. Alright, and we've got our thing. We've got our string. Again, let's just remove this printf for now. Alright, we've got our string. You can see our strings are now part of this, and the backslash n is converted to an actual non-printable character automatically, and things are going fine, right? Things are going as expected. Now, this is what we have done with our parser, with our lexer. Again, we have updated our lexer a bit. Now, we have to parse it. The next thing we need to do is here, the parsing. First, let's start with the function. This is okay. This is a statement type. It is statement type. Scope or normal. Again, these are statements. These are statements. These are statements. Now. If it is a scope, what exactly is a scope? What exactly is a scope? Alright, this is a statement. Statement data. Statement data. AST node may itself be a statement. AST node is a statement. So it will have the struct statement. AST statement data. Alright, we got a data. Struct. We got a AST statement data. Now we also need a the parent node and the child node struct. AST node pointer. Parent and children. Now this is going to be 64 children max, or rather the children, let's say maximum of children. I'm going to specify the maximum number of statements inside a scope. Now this two should be dynamically allocated, but just for the sake of simplicity, let's keep a absurdly huge number. Let's say 4096, that's the maximum size inside a scope. Well, that's good enough for our cases. Let's go. Let's keep it even more. Who cares? No? Let's say it's a pointer. It's just a pointer. That doesn't matter how big it is. Right? Let's say 1024 times 8. Now also we need size of children. AST node, we have done our AST node. Now we need to have a global node. So we have a global node, pointer, again pointer, current node. Okay. Now I'll create two helper functions to work with nodes, with AST nodes. Static AST node pointer, free the AST node. How to do it means here, this is a dynamically allocated entity, right? If node dot size, then we will loop through all the children's equals to 0, I is less than children node children count, and I plus plus. Now if no, we just want to delete it, no free. Now we're going to call this recursively because of this. So node children I. Now once its children is deleted, we will delete the node itself. So we'll do free node. Alright, we're done with that. Now creating a node. We have to create, or rather make, or rather new. It's a new, better new. What exactly do we need as parameters? So we need the statement data. Or rather, let's just ignore the statement data for now. And just we need the type, parent, and you don't need children. We can add children data. We can add children data, right? AST node pointer node equals to malloc. We're going to allocate the memory for the node. So if node equals to null, it will also return null. Alright, like it failed to allocate a node. Then let's just set the defaults of the node. So node.children count 0, and node.parent equals to parent, node dot data. Let's just initialize the data later. Statement type equals to type word. Now this is done. We are done with the nodes. Creating the helper functions of it. Next, we have to compile it. How exactly are we going to compile it? Let's see. First, if we encounter the func thing, alright, let's just say token like let's just parse the statements first. Alright, so first let's see if we encounter the func thing, for example. Buffer, let's keep the buffer here. Let's keep it even more. Let's make it bigger. Now, rather than printing it out, let's see if we can make sense of it. If it is func, if strcmp buffer func, if it is a function, what will we do? If it is a function, we have to check. We will you're sure to have the function name next to it. So we're just going to call this next token again, and we got our function name. Alright. So we're going to make a new node, AST node. Alright. So also let's just start with compilation. Alright, let's just compilation. Global node equals to node new AST node. The statement type normal, and this will be null, and this will be free AST node. Rather we have free AST node, global node, and current node equals to global node, right? Because we're having to initialize the global node, and we have to point the current node will be pointing to global node at the first at the beginning of the program. Now whenever we're going to encounter a new scope, we are going to add a new node as a child to that global node, and we're just going to make that the current node and add the next functions to the next statements to it. Whenever we encounter an end, we'll go back to the parent node. However, if we try to go back to the parent node and we see it is null, that means we have some kind of syntax error, right? So let's just continue with it. This is the function name. We got the function name. So Alright, so let's just make a function again as handy function. Static struct AST node pointer add a child. You just need to add a child, that's important. Because yeah, it's two line code, but it's going to be repeated a lot of times. No current node children count plus plus equals to this simple. Right? But this is going to be used a lot of times. So I just expect it to have it. Now next token. AC node equals to new node statement type. A statement type will be a scope, and the parent will be the current node. Alright, so the current node is the parent. Now, with this setup, we are allowed to have functions inside functions, right? However, we are not going to do that for now. Like, let's just ignore it for now. Right? Now, next node dot data dot character value, or rather strcpy string complete, then buffer. That's it, because we just going to do. Okay, we're going to do string.html. Now we're including string.html. We're going to copy the function name into the node string of a string value, alright, and also let's define the instructions. Right, I don't think we need more for now. Let's just try and keep going with this much. If we need, we can add it later. Now we have copied that in node data dot instruction is func, alright. Then add child current node, alright. We're just gonna add this as a child, and current node equals to node. Also, we don't need function definitions exactly because we're going to transpile it into C. So we don't exactly need these function signatures, because also we don't need function signatures because we don't need to. We're not going to check whether the function call is correct. We cannot check whether the function call is correct because we're actually pushing it into the stack. Right? So there is no proper function call. So we don't need to have function definition. Function signatures defined like in C. We need to have that. Right. So we're done with the function node. Right. For example, now else if one more important thing. This if it encounters an end, what will it do? It will do nothing but current node equals to current node parent. Current node equals to current node's parent, right? It's going to become its parent. And that's it with end. Now this will work with both end for if, that will work for end with main, it will work for end with functions for while loops for everything, alright? You need to have, we are done with this now. Next thing is, you need to have